In a moment, we're going to step backward through time, not merely centuries or millennia, but tens of thousands of years, to a world almost unrecognizable to modern eyes. We're traveling to the final chapter of the Ice Age, to a period when the Earth was gripped in a cold that would seem incomprehensible to us now. Vast sheets of ice crown the northern continents. The sea levels stood hundreds of feet lower than today, and across the frozen tundra and grasslands of the northern hemisphere roamed creatures of staggering size and power, the woolly mammoths. These were not mere elephants, though they were cousins to the creatures we know today. They were titans of their time, shaggy giants that typically weighed between 6 and 8 tons, standing about 10 to 11 feet tall at the shoulder, roughly comparable to the largest modern African elephants, draped in long reddish-brown hair that hung nearly to the ground. And they were everywhere. In Siberia, in northern Europe, across the icy steppes of what is now Russia and Alaska, mammoth herds moved in vast numbers, their enormous presence shaping the very landscape they inhabited. But then, in the span of a few thousand years, which, in geological time, is nothing more than a heartbeat, they were gone. These magnificent creatures, which had survived multiple ice ages and thrived for millions of years, vanished into extinction, and we're still asking why. Tonight, we're going to explore that vanishing. We'll walk through the Ice Age world that the mammoths inhabited. We'll meet the humans who shared that landscape with them, the first hunters who tracked these creatures across frozen wastes and learned to bring them down. We'll examine the climate that was changing beneath their feet. And we'll contemplate the great mystery that still haunts paleontologists and archaeologists. Was it the spear, or was it the shifting seasons that finally sealed the mammoth's fate? This is not a story of simple answers. It's a mystery wrapped in ice, written in bone and ash, and ancient DNA, still yielding its secrets to modern science. So, settle in. Let your mind drift backward through time. We're about to enter a world of ice and giants. To understand the mammoths, we must first understand the world they inherited. Imagine standing on the edge of a vast continental glacier sometime around 30,000 years ago. The ice sheet before you is incomprehensibly massive, thousands of feet thick in places, a frozen ocean that covers much of what is now Canada, Scandinavia, and northern Asia. The sun, when it appears through the perpetual overcast, casts a weak, watery light across a landscape stripped almost bare of trees. This is not desert, but it is equally hostile to dense vegetation. The air is dry, the soil perpetually locked in permafrost. Yet life thrives here, adapted to conditions that would seem utterly inhospitable to modern sensibilities. This is the world of the mammoth steppe, a name paleontologists have given to the vast grasslands and tundra that dominated the northern regions of Eurasia and North America during the last glacial maximum. It was not a monolithic landscape. It shifted and varied with latitude and local conditions. But everywhere, the cold was absolute. Temperatures that could plunge to 50 degrees below zero in winter. Winds that howled across open plains with nothing to break their force. A landscape so barren and so hostile that merely surviving here required extraordinary biological innovations. The woolly mammoth, Mammothus primigenius, represented evolution's brilliant answer to these brutal conditions. To understand them, imagine the elephant you know, then remaking it for an ice age. The woolly mammoth was smaller than its African cousins, an adaptation that reduced surface area and the energy required to maintain body temperature. An adult male might stand about 10 feet tall at the shoulder, somewhat shorter than a modern African elephant, though comparable in overall presence. Weight varied considerably, with typical adults reaching 6 to 8 tons, Though the largest recorded specimens may have exceeded 8 tons, the body itself was built for insulation. A thick layer of blubber, perhaps an inch to 3 inches deep, lay directly beneath the skin, creating a thermal shell that minimized heat loss. Over this, the mammoths were covered in a double coat of hair, a coarse outer layer measuring up to 20 inches long and a dense inner undercoat that trapped air and provided extraordinary insulation. This fur was typically dark brown or reddish brown, though it could fade to blonde at the tips, giving living mammoths a distinctive appearance that differs from reconstructions in museums. The fur was so effective that mammoths could thermoregulate, maintain their body temperature, even in conditions that would kill a modern elephant in hours. The head was distinctive as well. A woolly mammoth possessed a pronounced dome of fat and muscle on the crown of its skull, giving it a bulbous, almost comical appearance when compared to modern elephants. This wasn't vestigial, it served a purpose, likely as both a display structure and a reserve of calories that could be mobilized during harsh winters. The ears, too, were remarkably reduced compared to African elephants, smaller in absolute size and relative proportion, another adaptation to conserve heat. Large ears, useful in warm climates for radiating excess heat, would have been a liability in the Pleistocene world. And then there were the tusks. The woolly mammoth bore magnificent tusks that could reach 16 feet in length or more, though 12 to 14 feet was more typical. These curved upward and often inward, creating a distinctive profile that you would recognize in an instant if you saw a reconstruction. The tusks were not mere ornaments. They served practical purposes, scraping ice and snow from vegetation, fighting during competition for mates, and likely manipulating their environment in various ways we can only partially infer. The teeth reveal much about how these creatures lived. The molars of mammoths were vast, complex structures with multiple ridges designed for grinding the tough, fibrous vegetation of the steppe. Mammoths were specialized grazers and browsers, feeding on grasses, sedges, shrubs, and whatever woody vegetation they could find. They required enormous quantities of food. Estimates suggest roughly 180 to 200 pounds of vegetation per day for an adult, potentially foraging for as many as 20 hours daily. Moving across the landscape in herds, mammoths were not merely inhabitants of the Ice Age world. They were ecosystem engineers, their grazing and browsing shaping the vegetation patterns across vast territories. The temperature adaptations extended to every system. Their digestive system was modified to extract maximum nutrition from poor quality forage. Their circulatory system, with smaller blood vessels near the skin to minimize heat loss, was constantly adapted to their environment. Their metabolism itself seemed to operate differently from modern elephants, burning fuel with remarkable efficiency even in the brutal cold. In size and strength, the woolly mammoth had no predators among other animals. An adult was simply too large, too powerful, too equipped with formidable tusks and bulk. Only humans, when they appeared in sufficient numbers with adequate weapons, posed a threat to these creatures. Yet for nearly 1 million years before humans arrived in significant numbers, mammoths flourished. They appeared in the Pleistocene record roughly 2 million years ago, descended from African elephant ancestors. They survived the ice ages of the Middle Pleistocene, watched empires of ice rise and fall, and evolved to perfection in the cold world. By the time of our story, the last 15,000 years of the Ice Age, mammoths had achieved a kind of dominance on the northern steppe. Massive herds roamed across Siberia, across the plains of northern Europe, across what is now Alaska and the Yukon. They were not alone. Other megafauna shared the landscape: woolly rhinoceroses, bison, horses, cave bears, saber-toothed cats, and others. But the mammoths were iconic. supreme in their ecological role. And then came change, slow at first, then accelerating, climatic fluctuations that began to alter the world around them. The first signs were subtle, shifts in temperature patterns, changes in precipitation, the slow transformation of the landscape. The grasslands that had fed mammoth herds for millennia began to change. Trees crept northward. The climate became less stable, less predictable. And alongside this environmental transformation came another force, humans, spreading rapidly across the continents, developing new technologies, new strategies for hunting, new ways of organizing their societies. The mammoths, for all their size and power and evolutionary success, stood at the threshold of their extinction. They did not know it. There was no moment of awareness, no prophetic understanding that their reign was ending, but the forces that would drive them to oblivion were already in motion in the warming climate, in the changing vegetation, and in the clever, adaptable minds of the humans who hunted them. When humans first encountered the mammoths, we do not know. The fossil and archaeological record is incomplete, fragmented across continents, and obscured by the passage of tens of thousands of years. But we can trace, with increasing confidence, when modern humans, Homo sapiens, began to inhabit the territories where mammoths roamed. By 50,000 years ago, modern humans had reached northern Eurasia. They moved out of Africa in waves, dispersing across the Mediterranean, through the Middle East, down the coasts of Asia, and northward into the colder regions of Central Asia. They were not the first hominins to encounter mammoths. Neanderthals, who inhabited Europe and Western Asia, certainly encountered them and likely hunted them. Evidence from Neanderthal sites suggests they understood how to track large prey, how to coordinate hunts, and how to exploit the remains of dead animals. But it was modern humans who, when they arrived, began a systematic relationship with mammoths unlike anything that had come before. The reasons are manifold. Modern humans possessed language of a sophistication that allowed them to plan hunts in detail, to organize complex group strategies, and to pass knowledge from one generation to the next with precision. They possessed superior projectile weapons, spears tipped with carefully crafted stone points, and later, more sophisticated designs. They possessed social organization that allowed them to live in larger groups and to mount coordinated hunting expeditions. They possessed creativity and adaptability that allowed them to modify their strategies based on landscape and season. When early modern humans encountered mammoths, they recognized them immediately as a resource of almost incomprehensible value. A single mammoth could provide meat for a large group for weeks. The bones could be fashioned into shelters, tools, weapons, and art objects. The tusks could be carved into ornaments. The skin could be worked into clothing and shelter. The fat could provide calories and fuel for fires. In an Ice Age landscape where resources were often scarce and seasons unpredictable, a mammoth was wealth beyond measure. At a site called Dolní Věstonice in what is now the Czech Republic, archaeologists have uncovered evidence of mammoth hunting and processing dating to roughly 26,000 to 27,000 years ago, during the Gravettian period. The site reveals a sophisticated approach to handling mammoth remains. Cut marks on bones suggest careful butchering. Accumulations of mammoth and other bones suggest repeated hunting or the processing of carcasses at this location. Structures built from mammoth bones, arrangements of tusks and long bones that may have served as frameworks for hide tents, indicate advanced planning and construction expertise. The hunters of Dolní Věstonice had learned not merely to kill mammoths, but to integrate them into every aspect of their existence. Across Siberia and the Arctic regions, similar evidence accumulates. The Malta culture, dated to around 24,000 years ago, shows clear evidence of mammoth hunting and exploitation. Settlements were often placed in locations where mammoths could be efficiently intercepted or driven. Bone and ivory working reached extraordinary levels of sophistication, with artisans creating intricate carvings of mammoths themselves. Small figurines that suggest these creatures held deep cultural significance beyond their practical value. The hunting of mammoths was not casual. It was not a matter of individuals wandering out and hoping to encounter prey. It was organized, systematic, and built on accumulated knowledge. Hunters understood mammoth behavior. They knew migration routes and seasonal movements. They understood that mammoths were intelligent, social creatures that lived in family groups led by matriarchs. They understood the dangers of hunting such powerful animals and the need for coordinated strategy. The evidence suggests that mammoth hunts often exploited the natural landscape. Drives, pushing herds toward ravines or into boggy ground, were a common technique. A group of hunters working together could panic a herd and direct them toward geographic features that would slow them down or trap them. Once bogged down or cornered, individual mammoths could be dispatched with spears and projectiles. It was dangerous work. Hunters undoubtedly died. But for a coordinated group with adequate weapons, a mammoth could be killed, and the rewards were extraordinary. As thousands of years passed, the techniques refined. By 15,000 years ago, some of the most sophisticated mammoth hunting evidence appears in the archaeological record. At a site called Sungir in western Russia, a large mammoth processing area revealed remains of dozens of mammoths, suggesting either repeated hunts at the same location over many years or a mass kill event. The bones were meticulously butchered. Cut bones accumulated in specific patterns that suggest organized food processing. The ivory was worked into tools and ornaments of remarkable sophistication. But hunting mammoths was not universal among all human populations. In some regions, particularly in southern Europe and Africa, mammoths were absent or rare, and humans developed their hunting cultures around other megafauna or smaller game. The mammoth hunters were concentrated in the northern steppe regions, in Siberia, in northern Europe, in the territories where mammoths thrived. These populations developed distinct cultures, distinct traditions, and distinct relationships with the world around them. By the last glacial maximum, around 20,000 years ago, we see evidence of humans whose lives were intimately bound to mammoths. Some researchers have suggested that in certain regions, mammoths may have composed the majority of large meat consumed by human populations. The relationship was symbiotic in some sense. Mammoths provided calories and raw materials, and humans, in turn, became skilled predators of mammoths. Yet within this success lay a tension. As human populations grew, as hunting techniques became more refined, as settlements became larger and more permanent, the pressure on mammoth populations increased. It is impossible to know exactly how many mammoths were hunted per year, but archaeological evidence suggests the number was significant. In some regions, especially those with large human populations and long hunting traditions, mammoth populations may have been under considerable stress. This, then, was the situation in the period we must now examine, roughly from 15,000 years ago to 10,000 years ago. Mammoths still roamed in substantial numbers, but they faced pressures on two fronts: a climate that was beginning to change in ways that transformed their habitat, and human hunters who had learned to kill them with impressive efficiency. What would unfold over the next few millennia would determine whether mammoths could survive in a world increasingly inhospitable to them. To understand the extinction of the mammoths, we must understand that they did not vanish all at once. They did not disappear overnight. Rather, they faded, declining gradually across different regions at different times until finally scattered populations persisted only in the most remote areas, in the far Arctic, in islands isolated from human contact. And this decline coincided with one of the most dramatic climatic transformations in human history. Around 18,000 years ago, Earth began to warm. The transition was not smooth or steady. Climate science has revealed that the warming proceeded in fits and starts, with periods of rapid change interspersed with phases of stabilization or even brief reversals. But the overall trajectory was unambiguous. The ice ages were ending. The glacial system that had locked much of the northern continents began to destabilize. Vast ice sheets, which had persisted for nearly 100,000 years, accumulated mass at their bases from meltwater. This lubrication allowed them to carve enormous icebergs into the ocean. Around 14,000 years ago, the North American ice sheet collapsed in regions, releasing fresh water into the Atlantic in quantities so enormous that they disrupted ocean currents, temporarily plunging the region into a return to Ice Age conditions. This event, known to paleoclimatologists as the Younger Dryas, lasted roughly 1,200 years, a brief, intense return to harsh conditions in the midst of an overall warming trend. But the Younger Dryas was a dramatic exception. The general pattern was warming, deglaciation, and transformation of terrestrial environments. As temperatures rose, gradually at first, then more rapidly, the boundaries of the Mammoth steppe began to shift. The permafrost, which had been stable for millennia, became unstable. The climate became less arid. Precipitation patterns shifted. The consequences for vegetation were profound. The open steppe grasslands that had dominated the landscape during the Ice Age, grasslands that were maintained partly by the climate and partly by the grazing pressure of massive herbivore herds like mammoths, began to transform. Trees crept northward, advancing slowly but relentlessly from the tundra margins. Willow, birch, and other boreal species began to establish themselves in regions that had been treeless tundra for thousands of years. This transformation of vegetation was not a catastrophe in itself. Many animals adapted well to changing conditions. Horses, bison, and other herbivores remained abundant or even increased in some regions. But for mammoths, the transformation was problematic. Their digestive system, their size, their metabolism had all evolved in response to the specific conditions of the Ice Age steppe. They were specialists adapted to harsh cold and specific forage types. As the climate became more temperate, as the vegetation became denser and more woody, mammoths found themselves increasingly poorly adapted. Pollen cores extracted from ancient sediments reveal this transformation in precise detail. Deep in the Siberian permafrost, preserved layers of peat and soil accumulated year after year, century after century. Each layer represents a season or year of deposition. The pollen grains preserved in these layers indicate the vegetation that was growing at that time. Scientists can extract these cores, count and identify the pollen grains, and reconstruct the history of vegetation change with remarkable precision. What they found is that across much of the Mammoths range, particularly in northern Siberia, the shift from grassland to shrub and forest tundra was relatively rapid. In some regions, the shift from mammoth-friendly steppe conditions to more forested conditions occurred over just a few centuries. For an animal with a lifespan of 60 or 70 years, this would be imperceptible, a gradual change happening across the lifetime of multiple generations. But it was relentless. Another factor compounded these challenges: the rise of sea levels. As the massive ice sheets melted, sea level rose dramatically. The coastlines of Asia and North America, which had extended far outward during the Ice Age when sea levels were lower, were inundated. Islands that had been connected to the mainland became isolated. large land masses were converted to shallow seas and marshes. For mammoth populations, this had specific consequences. Herds that had used coastal routes for i.e. migration found those routes cut off or transformed into impassable marshland. Genetic evidence from ancient mammoth DNA reveals that island populations became isolated from mainland herds, their genetic diversity declining as they could no longer interbreed with larger continental populations. Isolated populations, smaller in total number, are always more vulnerable to extinction. A disease, a harsh winter, a run of bad years, and an isolated population can simply cease to exist. The most dramatic example was on an island called Wrangel Island, located in the Arctic Ocean off the coast of northern Siberia. Wrangel Island harbored a population of mammoths that persisted even after mammoths had vanished from most of the world. How did they survive? The island's climate was harsh even by Ice Age standards, but it remained relatively open and steppe-like even as the mainland transformed into forest and shrub tundra. The mammoths of Wrangel Island, isolated by rising seas, persisted on this small island in the Arctic for thousands of years after their mainland cousins had vanished. They were, in effect, a living fossil, a remnant population clinging to existence in a world that was becoming increasingly hostile to their kind. But the climate changes were not merely local. They were global in scope. Ocean temperatures rose, monsoon patterns shifted, desert margins advanced and retreated, tropical forests transformed. And through it all, the basic trajectory was the same, a shift from Ice Age conditions to conditions more like those we experience today, warmer, wetter, and with more diverse and dense vegetation. For mammoths, this transformation meant that habitat was disappearing. It was not that mammoths were suddenly incapable of surviving in the new world. Rather, their preferred habitat, the cold, dry, open steppe grasslands, was shrinking, becoming fragmented into smaller and smaller patches. Their food sources were changing. The plants they depended on were being replaced by species that were less nutritious or less abundant. The seasonal rhythms that had guided mammoth herds' migrations for millennia were shifting, becoming unpredictable. Imagine you are a mammoth matriarch leading your herd across the landscape as your kind had for millennia. The routes you have always taken, the seasonal movements that have guided your kind for generations, begin to change. The grasslands where you once found abundant food are transforming into shrub and forest. Water sources are becoming more unpredictable. The long winters, while still harsh, are becoming increasingly variable. Some years still brutally cold, other years relatively mild, but all of them becoming harder to predict in advance. For a creature whose survival was built on predictability, on knowing the landscape intimately, on following inherited routes and strategies, this uncertainty was profoundly destabilizing. The mammoths, for all their size and power, were becoming increasingly vulnerable to a world that was changing faster than evolution, faster than cultural knowledge, faster than adaptation could accommodate. Yet mammoths did not vanish evenly across their range. The extinction was not simultaneous, not a coordinated collapse of all populations at once. Rather, it was a gradual retreat and decline, with populations disappearing from some regions while persisting in others, retreating northward and eastward as the world warmed. By around 12,000 years ago, mammoths had vanished from most of their range in Europe. Archaeological and paleontological evidence indicates that mammoths, while still present around 15,000 years ago, had become increasingly rare by 13,000 years ago and had effectively disappeared from the European mainland by 12,000 years ago. This period of decline corresponds to the Bowling Oscillation and the subsequent warming that characterized the end of the last glacial period. This period, interestingly, corresponds to the warm phase known as the Bowling Oscillation, a period of rapid warming that occurred between the coldest phases of the last ice age. The retreat was not linear. Mammoths clung to certain refugia, regions where conditions remained relatively favorable. The northern steppes of Siberia were one such region. Here, because of oceanic influences and local climate patterns, the climate remained sufficiently cold and the vegetation remained sufficiently open that mammoths could persist. Archaeological evidence suggests that mammoth hunting continued in Siberia well into the period from 12,000 to 10,000 years ago, later than in most other parts of the world. The people who hunted mammoths in these final millennia were not living in a world fundamentally different from the one their ancestors had inhabited. There were changes, certainly. The climate was warmer, the world was becoming less predictable, but the mammoths were still there, still available to hunters, still providing the resources that sustained human populations. At sites like Malta in Siberia, dated to around 16,000 to 15,000 years ago, and at more recent sites extending down toward 10,000 years ago, evidence of human mammoth hunting persists, but the archaeological record also suggests changes in human behavior. Mammoth bones, which had been used extensively to construct dwellings and worked into sophisticated tools and ornaments, become less frequent in the archaeological deposits of later periods. This could indicate that mammoths themselves were becoming rarer, less frequently encountered and killed. Or it could indicate changes in human subsistence practices. Perhaps mammoths remained present, but human hunters were turning increasingly to other prey as mammoth populations declined. By 10,000 years ago, the end of the last ice age had arrived. The younger Dryas cold phase had passed. The climate warmed rapidly. Human societies across much of the world were transitioning toward agriculture, settling into permanent villages, beginning to cultivate plants and domesticate animals. In much of Europe, Asia, and the Americas, the hunting of large Ice Age megafauna was becoming a thing of the past. Yet mammoths persisted. The archaeological evidence suggests that in certain remote regions, mammoths survived well into the early post-glacial period. In Siberia, some evidence suggests mammoths persisted until roughly 10,000 years ago or perhaps even later, though this remains debated among specialists. The most dramatic evidence of late surviving mammoths comes from islands. Wrangel Island, isolated in the Arctic, harbored a mammoth population that persisted even after mammoths had vanished from the mainland. Radiocarbon dating of mammoth bones from Wrangel Island indicates that mammoths there survived until around 3,700 years ago, an astounding 5,000 years after their mainland populations had vanished. These Wrangel Island mammoths were small, much smaller than their Ice Age ancestors. Genetic analysis has revealed why. They were isolated inbred populations. The island was too small to maintain the genetic diversity necessary for robust populations. They were relics, clinging to existence on an Arctic island as the world around them transformed. They adapted, becoming smaller, perhaps more efficient, at surviving on the limited resources available. But ultimately, even these adaptations could not save them. By roughly 3,000 years ago, mammoths had vanished entirely. The reign of Mammothus primigenius, a species that had dominated the Ice Age world for nearly 1 million years, had come to an end. Why did Wrangel Island mammoths persist so long after their mainland cousins? Part of the answer lies in the preservation of favorable conditions on the island. Wrangel, due to its specific geographic location and climate patterns, remained open and steppe-like even as the mainland was transforming into forest. The mammoths could find the grasslands and sparse vegetation they needed. They were protected, in a sense, from the full force of the climatic changes reshaping the world. But Wrangel Island was isolated. The mammoths there could not migrate, could not interbreed with mainland populations, could not benefit from the genetic diversity that large, interconnected populations maintain. In genetic terms, they were slowly declining. Studies of ancient DNA extracted from Wrangel Island mammoths show that their genetic diversity was very low, lower than populations of Ice Age mammoths that roamed the mainland thousands of years earlier. They were essentially dying out slowly, their populations unable to reproduce at rates sufficient to offset natural mortality. Did humans have any impact on the final extinction of Wrangel Island mammoths? The evidence remains ambiguous and debated. Humans did eventually reach Wrangel Island, with the earliest archaeological evidence dating to around 3,600 years ago, only a few centuries after the most recent known mammoth remains. It is possible that the arrival of humans delivered the final blow to an already dwindling population. However, recent analyses suggest mammoths may have already been extinct for several centuries before human arrival, making hunting unlikely to have been the primary driver. The true cause of the final extinction remains uncertain and may have involved a combination of factors including extreme weather events, the accumulated effects of isolation on small populations, and possibly human predation. The extinction of mainland mammoths by around 10,000 years ago was almost certainly due to a combination of factors. Climate change was certainly one. The transformation from Ice Age to post-glacial conditions fundamentally altered the landscape mammoths inhabited. The transformation of their preferred habitats was real and profound. But human hunting also played a role. The evidence is contested among scientists. Some argue that hunting was the primary factor. Others argue for climate change. Most modern researchers accept that both factors contributed in different ways in different regions. In some areas with large human populations and strong hunting traditions, perhaps human pressure was more significant. In other regions with less human presence, perhaps climate was more determinative. What seems clear, however, is that neither factor alone was sufficient to explain the extinction. Mammoths had survived previous climate changes. They had survived the Younger Dryas, a period of rapid return to Ice Age conditions just 11,000 years ago. But by that time, human populations were numerous and skilled hunters, and mammoth populations had already been declining. The combination of these stressors, climate change reducing habitat quality, hunting reducing populations, genetic isolation, reducing diversity in isolated populations, created a situation from which mammoths could not recover. Let us now pause and consider the world from the perspective of those humans who lived alongside mammoths, who hunted them, who built their cultures around these magnificent creatures. Imagine yourself as a young hunter in northern Siberia, perhaps 12,000 years ago. The world you inhabit would be recognizable in broad strokes to a modern human. The seasons turn. Winter brings cold and hardship. Spring brings renewal. Summer provides abundance. Fall is a time of preparation. But the specifics would be alien. The landscape around your camp is open steppe, grassland rolling toward horizons unmarked by the distant trees of modern Siberia. The air is cold, not the brutal, withering cold of the deepest ice age, but still harsh, still demanding. Distances across the landscape are immense. A journey that might take a person a day or two of walking in modern terrain could take much longer here. The ground uneven, the vegetation clinging, the weather unpredictable. Your people are hunters. Your identity as a person, your status within the group, your sense of self are tied directly to your ability to hunt. You have grown up learning the skills of pursuit, the reading of animal signs, the craft of weapons making. You can track a mammoth across open ground. You understand how these creatures move, how they respond to threats, how they protect their young. Mammoth hunts are the great events of your people's year. When word comes that a herd has been spotted, there is mobilization. Men gather, weapons are prepared, strategies are discussed. There is an understanding passed down through generations of how to approach mammoths, how to coordinate a group hunt, how to avoid the greatest dangers. A successful mammoth hunt is transformative. When your group brings down a mammoth, the meat feeds you through harsh seasons. The bones are carried to your settlement, where they become shelters, tools, ornaments, and fuel for fires. The tusks are the most prized. They are worked into intricate carvings, fashioned into harpoon points, incorporated into jewelry that marks your status and your participation in the hunt. But as the years pass and your own lifetime spans decades, you notice changes. The mammoths are becoming rarer. Hunts that once yielded success with relative regularity now sometimes end in failure. You travel farther to find herds. The routes you have learned from your father and grandfather are becoming less predictable. Some of the herds that once migrated through certain territories in certain seasons are no longer appearing. Your people are adaptable, however. As mammoths become scarcer, you hunt other prey. Bison herds still roam the steppe in great numbers. Horses are still abundant. The woolly rhinoceros, while never as numerous as mammoths, still can be hunted successfully. Your diet becomes more diverse, less dependent on mammoths, more opportunistic. At the same time, the world itself is changing in ways that are perceptible even to pre-scientific observers. The winters, while still cold, become less predictable. Some years are brutally harsh, others are surprisingly mild. Storms move differently. The snow falls at different times, the vegetation is changing, trees are creeping northward from the far south. The grasslands where your herds have always ranged are becoming more speckled with shrub and small trees. For a people whose existence depends on intimate knowledge of landscape and seasons, these changes are deeply unsettling. The inherited knowledge passed down through generations, the maps of migration routes, the timing of seasonal movements, the locations of reliable water sources, this knowledge, which has guided your people successfully through many generations, is becoming less reliable. Perhaps your culture responds to this by developing new hunting strategies. Evidence from archaeological sites suggests that as the Ice Age ended, human hunting techniques became more diverse and more focused on varied prey. Your people may transition from specializing in large megafauna to a more generalized hunting strategy, taking smaller animals, fishing in rivers and streams, collecting plant resources more systematically. Or perhaps your culture enters a period of disruption and change. Some groups may merge with neighbors, creating larger populations that can share resources and knowledge. Other groups may abandon the steppe entirely, moving northward in search of remaining mammoths and open landscape, or southward where new opportunities are emerging as the climate warms. The extinction of mammoths was not experienced by these hunters, I believe, as a dramatic catastrophe. It was not as if mammoths suddenly vanished, rather, it was a gradual decline generation by generation, a slow fading of the mammoths from the landscape. Hunters might not have perceived the overall trend, that mammoths were truly disappearing forever. They might have understood it as a cyclical variation, a period when mammoths were scarce, as had happened before, followed by a recovery. Or they might have understood it, as humans often do, with gradually unfolding changes, as normal, as simply the way the world was changing. By the time mammoths were truly extinct, by the time the last herds had vanished, and the species was gone from the earth, it had been so gradual that your cultural memory might not have grasped what had happened. The mammoths were gone, yes, but so too was the entire Ice Age world. So too was the climate that had shaped your culture and your existence. The world had transformed, and your people had transformed with it. Some of your people, in certain regions, became herders, domesticating the reindeer and other animals that thrived in the post-Ice Age Arctic. Other groups transitioned into the hunting and gathering of the forest ecosystems that were spreading northward. Still others abandoned hunting altogether, settling into permanent villages and beginning to farm. The cultures that had built their identities around mammoth hunting transformed into different cultures, adapted to different prey, different landscapes, different ways of living. The mammoths were gone. But the people who hunted them, the cultures that had evolved in tandem with these magnificent creatures, persisted and transformed. And in their art, their ornaments, their carved figurines of mammoths, we can still see the echo of that ancient relationship, a window into a world where giants roamed and humans hunted them under vast open skies. Now we arrive at one of the great unsolved mysteries of paleontology and archaeology. Why did mammoths go extinct? Was it climate change, the inexorable transformation of their habitat? Or was it human hunting, the spears and strategies of increasingly sophisticated predators? Or was it some combination of both, a convergence of stressors that overwhelmed the mammoth's capacity to adapt? This question has occupied scientists for decades. It remains contested, with passionate advocates on multiple sides, each presenting evidence that seems compelling, each identifying weaknesses in opposing arguments. There is no consensus, which itself is telling. The truth almost certainly is complicated. The climate change argument is straightforward and supported by substantial evidence. We have documented in considerable detail the warming of the climate from 18,000 years ago onward through analysis of ice cores, pollen records, and marine sediments. We have traced, through paleobotanical evidence, the transformation of vegetation from Ice Age, steppe, to post-glacial forest and shrub tundra. We have shown that this transformation occurred in the very regions where mammoths vanished. The inference seems logically compelling. Mammoths went extinct because their habitat fundamentally changed. But there are important complications to consider. First, mammoths had survived previous climate changes. During the Eemian interglacial, a warm period roughly 130,000 years ago, global temperatures were similar to or possibly warmer than today, yet mammoths persisted, adapted, and survived through that transition. The climate changes at the end of the last ice age were dramatic, but not unprecedented in the mammoth's evolutionary history. Why then could they not adapt this time? One answer might involve the rate of change. The warming at the end of the last ice age occurred relatively rapidly, over a span of centuries rather than millennia, faster than during previous climate transitions. For a species with a long generation time, mammoths reached sexual maturity at around 13 years and lived to 60 or 70, this might be too fast for evolutionary adaptation through natural selection. Cultural adaptation, learning new migration routes, finding new food sources, might also be insufficient when environmental changes occur at such a rapid pace. A second complication involves the specifics of vegetation change. The transformation from Ice Age steppe to post-glacial tundra was not merely a change in overall vegetation type. It was a transformation in the quality and quantity of forage available to mammoths. Ice Age steppe, while cold and harsh, was relatively open and dominated by nutritious grasses and herbs. The post-glacial vegetation, particularly in regions like Siberia, became increasingly dominated by shrubs and herbs less preferred by mammoths. The transformation of grasslands to shrub tundra meant that mammoths had to travel farther to find adequate food. They had to expend more energy to eat the same calories. They became less efficient. The hunting argument comes from a different direction. Humans are undeniably capable hunters. The archaeological evidence shows that humans hunted mammoths systematically and effectively for thousands of years. Sites like Dolny, Viestanica, Sungir, and others provide compelling evidence of mammoth processing and consumption on a substantial scale. The question is not whether humans could kill mammoths. The question is whether human hunting pressure was sufficient to drive mammoths to extinction. This is where the argument becomes contentious. Critics of the overkill hypothesis, the idea that humans hunted mammoths to extinction, point out that mammoth populations were likely enormous. A conservative estimate might place the global mammoth population in the tens of thousands, quite possibly in the hundreds of thousands. If humans were hunting mammoths at sustainable rates, if they were hunting only enough to support their own populations, then human hunting might be manageable by mammoth populations. Only if humans were hunting mammoths faster than they could reproduce would hunting be a genuine threat to population survival. But here is where the argument becomes subtle. Even if total human hunting pressure was not sufficient to drive mammoths extinct on its own, hunting combined with climate stress could be. Imagine a mammoth population stressed by climate change, adapting to new vegetation, forced to travel farther for adequate food, experiencing reduced reproductive success. In this weakened state, even moderate hunting pressure could tip the balance from sustainability to decline. A population that could withstand hunting pressure during good times might collapse during times of environmental stress. Moreover, human hunting pressure was not uniform across space and time. In regions with high human population densities and long traditions of mammoth hunting, particularly in northern Europe and western Siberia, hunting pressure may have been intense. In these regions, mammoths may have been hunted to local extinction well before climate change alone would have eliminated them from those specific areas. In other regions with lower human population densities, climate change may have been the more dominant factor. The extinction of mammoths was not a single, universal event, but rather a series of regional and local extinctions, each potentially driven by different combinations of factors. This complexity means that no single simple explanation satisfies all cases. The most compelling evidence for a combination of factors comes from genetic analysis of ancient mammoth DNA. Scientists have extracted and sequenced DNA from frozen mammoth remains, creating a genetic record of mammoth populations over time. This genetic record reveals something striking. Mammoth genetic diversity declined over the course of the late Pleistocene, culminating in very low genetic diversity by the time mammoths were extinct. Why does genetic diversity matter? Because genetic diversity is essential for population resilience. A genetically diverse population has more variation in traits related to disease resistance, environmental tolerance, and reproductive success. A genetically homogeneous population is vulnerable to disease, environmental stress, and the accumulation of deleterious mutations. The low genetic diversity in late Pleistocene mammoths suggests that their populations were declining, becoming smaller, more isolated, less diverse, long before the final extinction. Why were populations becoming smaller and more isolated? Climate change would certainly contribute. As habitat became fragmented, populations would become isolated from one another. But hunting pressure would also contribute. If humans were selectively hunting mammoths in certain regions, they would reduce local populations. If hunting pressure was sufficient to eliminate mammoths from certain regions, it would reduce the geographic range of the species and fragment populations. The archaeological record also provides hints about the trajectory of human-mammoth interaction. In Europe, mammoths vanished around 12,000 years ago, relatively early in the post-glacial period. The archaeological evidence from Europe suggests that mammoths were hunted intensively during the late Pleistocene, with substantial mammoth kill sites concentrated in certain regions. When mammoths disappeared from Europe, human hunters transitioned to hunting other prey, reindeer, horses, bison. The transition seems relatively seamless. Humans did not suffer population collapse or cultural disruption when mammoths vanished. This suggests that human populations were not entirely dependent on mammoths, that they could sustain themselves on alternative prey. In Siberia, by contrast, mammoths persisted longer, and the evidence for intensive mammoth hunting is perhaps less dramatic. This might suggest that hunting pressure was lower in Siberia, or that the climate remained more favorable for mammoths in that region, or both. The most reasonable interpretation, based on current evidence, is that mammoths went extinct as a result of convergent stressors. Climate change was fundamental. It transformed the landscape, altered the vegetation, fragmented populations. Hunting pressure, while perhaps not solely sufficient to drive extinction, added stress to already vulnerable populations. The combination pushed mammoths from decline into extinction. In some regions, hunting may have been more significant. In others, climate may have dominated. But both factors were likely present and important. The mammoths themselves have given us their voices, in a sense, through the preserved remains that emerge from the melting permafrost. Every summer in Siberia, as the permafrost surface thaws and the ancient ice releases its treasures, mammoth remains are discovered. Sometimes it is a single bone. Sometimes it is a more complete skeleton. Occasionally it is a nearly intact carcass preserved by the frozen ground with such fidelity that researchers can examine the contents of its stomach, can study its final meals, can determine the season of its death. These preserved mammoths tell us stories. In the 1990s, a young mammoth calf was discovered near Magadan in northeastern Russia. The specimen, estimated to be around 40,000 years old, was so well preserved that its fur and internal organs were intact. Researchers could determine what the calf had eaten in its final days, a diet of grasses and herbs typical of the Ice Age steppe. They could see that it had been healthy and well nourished. Then suddenly it died, likely killed by a predator or succumbing to disease or accident. The carcass was rapidly frozen, preserving it until the present day. Another remarkable specimen discovered on Wrangel Island was a juvenile mammoth that had lived perhaps only a few years before dying. The analysis of this individual revealed signs of inbreeding, asymmetrical tusks, skeletal irregularities that suggested genetic problems. This was one of the last mammoths living in the final refuge of Wrangel Island, bearing in its very bones the signs of genetic decline, the inevitable consequence of living in an isolated, shrinking population. Perhaps most poignant are the complete skeletons and partial mummies that emerge from the permafrost. They offer us a glimpse of individual lives. There was a male mammoth, preserved in northern Siberia, that bore the scars of survival, old injuries, healed fractures, evidence of attacks or accidents that it had survived. This individual had lived a life of challenge, had faced danger, had persisted. And yet, in the end, even this survivor vanished, dying as mammoths did across the continent. In 1977, a nearly complete woolly mammoth was discovered in the Sakha Republic of Russia, preserved so thoroughly that its body was sent to a museum where visitors could observe a genuine Ice Age creature. The specimen was a young adult male, perhaps 30 years old at death, with tusks still growing, his entire body wrapped in dark hair, his skin visible in places where the fur had worn away. Looking at this specimen, visitors can grasp viscerally what mammoths were, real creatures, individual animals with bodies and tissues and lives, not merely fossils or abstract concepts. The dental remains of mammoths also tell stories. The molars of mammoths show wear patterns that indicate their diet and their age. The molars of a young mammoth are less worn. Those of an elderly individual are worn down to the roots. By examining wear patterns, paleontologists can estimate the age of individual mammoths at death. And what they find is striking. The age distribution of dead mammoths in archaeological sites suggests that humans were hunting mammoths of all ages, including juveniles and calves. This tells us something important about human hunting strategy. We might have assumed that ancient hunters targeted primarily large, healthy adults, the most challenging prey, but also the most rewarding in terms of meat and resources. But the evidence suggests a less selective approach. Humans hunted entire family groups, mammoths of all ages. This would have been effective. A mother mammoth would defend her calf, making both vulnerable, but it would also have had consequences for population dynamics. If humans were killing breeding females and calves, they were directly reducing population reproduction rates. The tusks and bones preserved in archaeological sites carry their own messages. Carved mammoth ivory, worked into intricate figurines and harpoon points, speaks to the cultural significance these creatures held. The care and skill invested in these carvings, the sophistication of the designs, the prominence of mammoths in the art and material culture of the Upper Paleolithic, all suggest that mammoths were not merely food but central to the identity and imagination of the people who hunted them. In Siberia, arrangements of mammoth bones have been found that suggest structures, mammoth bone huts, frameworks of tusks and long bones arranged in patterns that might have supported hide coverings. These structures speak to the integration of mammoths into human material culture. Mammoths were not just prey, they were raw material, the foundation of the built environment, the medium through which humans shaped their world. The isotopic composition of mammoth teeth and bones provides another form of testimony. Isotopes are variants of elements that differ in their atomic mass. Plants and animals incorporate specific isotope ratios from their environment, and these ratios are incorporated into bones and teeth. By measuring isotope ratios in mammoth remains, scientists can reconstruct the diet and habitat preferences of individual mammoths. This research reveals that mammoths, even late in their history, remained specialized grazers. They consumed primarily grasses and herbaceous plants, with relatively little woody vegetation. As such, vegetation became scarcer. Mammoths would have had to travel farther to find adequate forage, stressing their populations. Ancient DNA tells perhaps the most sophisticated story. By extracting and analyzing DNA fragments from frozen mammoth remains, scientists have reconstructed the genetic history of the species over time. These studies reveal that the last mammoths, the individuals living 10,000 or 8,000 or even a few thousand years ago, were genetically very different from their ancestors of the Ice Age. They had lost genetic diversity, they showed signs of inbreeding, their populations had become smaller and more isolated. But the DNA also reveals something unexpected. There were at least two major genetic groups of woolly mammoths, suggesting that populations were divided geographically, perhaps by the landscape or by barriers created by human hunting or climate change. The isolation of these populations meant that if one group was extirpated, hunted to extinction or decimated by climate change, the others could not replenish it through migration and interbreeding. Each population decline was, in a sense, a step toward total extinction. The voices from the ice then speak of a species in decline. They speak of individual mammoths living and dying, of populations stressed and fragmenting, of a once dominant species retreating into smaller refugia, facing pressures from climate, from hunting, from the inexorable march of environmental change. They do not speak, these voices, of a sudden catastrophe or a clear moment of extinction. Rather, they speak of a slow fading, a gradual decline, a drawing down of a species that had once ranged across vast territories. What does it mean that the mammoths are gone? This question is not merely historical or scientific, it is philosophical and even emotional. The extinction of mammoths marks the end of an era, the close of one chapter of Earth's history and the opening of another. For millions of years, mammoths walked the Earth. They saw the great ice sheets advance and retreat. They survived climates that varied wildly. They evolved and adapted and persisted through multiple ice ages. And then, in a span of only a few thousand years, a mere instant in geological time, they vanished. Every mammoth that ever lived is now dead. Every individual that once walked the steppe has returned to dust. Their species is extinct, and all that remains is bone, ivory, and DNA fragments frozen in permafrost. The extinction of mammoths is often grouped with the extinction of other Ice Age megafauna. The woolly rhinoceros, the cave bear, the giant ground sloth, the saber-toothed cat, the dire wolf, the list goes on. These were creatures that dominated their ecosystems for millions of years, and then, in the span of a few thousand years, most of them vanished. This pattern of extinction, concentrated in the last 20,000 years, and particularly intensive in the last 10,000 years, is called the Pleistocene extinction or the megafaunal extinction event. The causes of this extinction event remain debated. Climate change was undoubtedly a factor. The transition from Ice Age to post-glacial conditions was one of the most dramatic environmental transformations of the Quaternary period. It fundamentally reshaped ecosystems. Species that were specialized for Ice Age conditions found themselves increasingly poorly adapted. But climate change, while certainly significant, does not seem to be the complete explanation. Most modern scientists accept that human hunting was also a major factor. Humans dispersed across all continents between 50,000 and 15,000 years ago. This dispersal coincided in many regions with the disappearance of large herbivores. In North America, many of the largest herbivores went extinct around 13,000 years ago, shortly after humans arrived in substantial numbers. In Australia, megafauna extinctions appear to have followed human arrival by a relatively short interval, though the timing is still debated. This temporal coincidence is striking and difficult to explain away. Perhaps the most reasonable interpretation is that human hunting, combined with climate stress, pushed many species toward extinction. Species that might have survived climate change alone, if given enough time to adapt, were unable to do so under the combined pressure of environmental transformation and systematic hunting. This is particularly true for large-bodied animals with slow reproduction rates, animals like mammoths that invested heavily in few offspring and had long generation times. Such species are inherently vulnerable to overhunting because they cannot replace losses quickly enough. The extinction of mammoths specifically has consequences that ripple across ecosystems even today. The mammoth steppe ecosystem, with its vast grasslands maintained partly by mammoth grazing, transformed into shrub tundra. This transformation had cascading effects on other species. Some thrived in the new environment, others declined or vanished. The ecosystem composition of the Arctic changed fundamentally. Some researchers have proposed that rewilding projects, reintroducing herbivores like horses and reindeer to Arctic regions to recreate something resembling the mammoth steppe ecosystem, could help mitigate climate change by maintaining grasslands instead of allowing shrubland to dominate. While the logic is speculative, it represents a form of environmental restoration inspired by the lost world of mammoths. The mammoths are gone, but the ideal they represent, a cool, open steppe ecosystem, persists in human imagination. The cultural significance of mammoth extinction is equally profound. For humans, the extinction of mammoths marked the end of a particular form of existence, the hunting of Ice Age megafauna as a primary economic strategy. As mammoths and other large prey disappeared, humans had to adapt their subsistence strategies. In some regions, this drove the transition toward agriculture and civilization. In others, it led to the development of more sophisticated hunting and gathering strategies focused on smaller game and diverse plant resources. The mammoths, in their extinction, left us a gift, though it is a gift that is also a mirror and a warning. The gift is testimony to the reality of extinction, to the fact that species, no matter how successful or dominant they may be, can vanish. The mirror shows us our own power, our capacity to reshape ecosystems and drive species to extinction. The warning reminds us that we now live in a world where human influence is dominant, where extinction is ongoing, where species continue to disappear at rates far exceeding natural background extinction rates. Today we live in what is called the Anthropocene, the epoch of human dominance. We shape the climate through greenhouse gas emissions, we fragment habitats through development, we hunt species to the brink of extinction, and the mammoths, though extinct, serve as a historical precedent, a reminder that yes, humans have driven species to extinction before and we are capable of doing so again, yet the mammoths also offer a kind of solace. We have not created a dead world, we have not eliminated all large animals. Many species persist, adapt, and thrive in the world humans have created. And new efforts, conservation programs, habitat restoration, sustainable management represent our growing awareness of our own power and our responsibility to wield it carefully. The mammoths are gone, but they are not forgotten. Every frozen carcass that emerges from the thawing permafrost, every carved ivory figurine displayed in a museum, every genetic sequence analyzed in a laboratory, every painting in a cave, these are acts of remembrance. We are keeping the mammoths alive in our imagination, our art, and our science. And in doing so, we are learning the lessons that extinction teaches. Let us imagine now the final days of mammoths, not as grand historical moments, but as the ordinary unfolding of individual lives in a changing world. Imagine you are a young mammoth, perhaps 5 years old, living in the last refugium of Wrangel Island roughly 4,000 years ago. Your mother led you here across the frozen sea in winter when the ice provided a bridge. Your herd is small, perhaps a few hundred individuals at most. The island is harsh but familiar. The grasslands still provide adequate forage, though the vegetation is sparse and you must range widely to find sufficient food. You have never known the vast herds of the mammoth steppe, the great congregations that ancient stories might speak of. For you, the world is limited. It is the island, the ice, the handful of individuals that constitute your entire world. You know your family intimately. Your mother is wisdom incarnate. Your elder sister is strength. The bulls that range across the northern territories are unfamiliar, met only occasionally during breeding seasons. Winter is harsh, as always. The snow accumulates. Ice forms thick on any available water. The vegetation becomes even sparser. Your mother knows where to dig for the dried grasses beneath the snow. She knows the roots that her mother taught her, and her mother's mother before her. These roots, this inherited knowledge, is nearly all that keeps your herd alive through the dark, frozen months. But this winter is harder than remembered. The snow comes earlier, the temperatures drop lower than in previous years. More snow means more digging, more energy expended, more caloric demand when food is scarce. You are hungry, not starving exactly, but not fully satisfied. Neither are the others. You can sense it in the behavior of the herd, in the way they range more desperately, in the increased tension between individuals competing for forage. Spring comes eventually, as it always does. The days lengthen, the temperature gradually rises, the vegetation begins to grow again. But the weaknesses incurred over the winter have their consequences. Calf born the previous spring, already vulnerable, succumbs to disease or simply lacks the reserves to recover. An elderly bull dies quietly in a ravine, his weakened body finally giving out. The herd is slightly smaller, slightly more stressed, slightly more vulnerable. This pattern repeats across generations. A harsh winter, a difficult spring, another harsh winter. Individuals lost to disease, to predation by the few wolves that still hunt the island, to simple exhaustion and age. The population does not recover. Each generation is smaller than the previous, each individual perhaps slightly smaller as well, their bodies adapting to inadequate nutrition. The genetic diversity continues to decline. Individuals are increasingly related to one another. The vigor of the population diminishes. You yourself bear the marks of this declining world. Your tusks are less impressive than those of your ancestors, your body less robust. Your calves, if you have them, are smaller and less vigorous than the calves of ancient mammoths might have been. Your world is diminishing, not just geographically. The island remains the same size, but demographically, genetically, vigorously. And then, around 4,000 years ago, new arrivals appear. Humans have finally reached Wrangel Island. They are few at first, but they hunt. They hunt you, hunt your kind, kill with surprising efficiency. You are struck by a spear, a wound that does not kill immediately but leaves you vulnerable, weakened, ultimately fatal. Or perhaps you escape this first encounter but are hunted relentlessly, driven from familiar grazing grounds, forced into ever smaller refugia. The population crashes, the balance, already precarious, tips. A population that was declining slowly becomes a population in free fall. Within a century or two, mammoths are gone from Wrangel Island. The last individual dies, alone perhaps, having failed to find a mate, having exhausted its reserves, having succumbed to cold or disease or hunger. The mammoths are extinct, not dramatically, not memorably, but simply ceased to exist. Nobody marked the moment. There was no funeral, no final gathering, no moment of recognition that a species had ended. The last mammoth simply died, and then there were no more mammoths. The ice continued to form and melt, the seasons continued to turn, the island continued to exist. Though it was now emptier, the ecosystem diminished by the absence of these great creatures. We do not know the names of the last mammoths. We do not know if they suffered. We do not know if they understood, in whatever manner mammoths understand, that they were the last, that their species was ending. We only know that they are gone, that a lineage lasting millions of years terminated, that an evolution shaped by ice ages and survival suddenly reached an end. Yet in one sense, the mammoths are not entirely gone. They persist in us, in our genetic memory, in the DNA fragments we have recovered, in the ivory and bone we have found, in the art and stories of the peoples who hunted them. They persist in our scientific understanding, in our efforts to reconstruct their lives through ice core data and isotope analysis. They persist in our imagination, in our fascination with these giants, our wonder at their size and power and beauty, and perhaps someday, through genetic engineering and cloning technology, mammoths may return. Scientists have proposed creating a genetic reconstruction of mammoths by inserting mammoth genes into Asian elephant genomes, creating a hybrid that might, in some sense, be a mammoth. Whether this is desirable, whether it is ethical, whether such creatures would truly be mammoths or merely facsimiles, these are questions still being debated. But the fact that we are asking them speaks to the power that mammoths exert on our imagination, even in extinction, perhaps especially in extinction. The mammoths vanished, but they did not vanish from memory, did not vanish from meaning, did not vanish from our understanding of the world and our place in it. And so, in a real sense, they persist still. The story of mammoths does not end with their extinction. Rather, extinction is a chapter in a longer narrative that continues even today, shaped by what we have learned from mammoths and what their story means for our present moment. In the scientific community, mammoths have become central to our understanding of extinction itself. The study of how mammoths vanished, the examination of the factors that contributed to their decline, has become a model for understanding other extinctions and for thinking about modern conservation. When scientists today discuss endangered species, tigers, elephants, rhinoceroses, they often reference mammoths, drawing parallels between the stresses that drove mammoths to extinction and the stresses facing modern species. The parallels are striking. Modern endangered species face habitat loss due to climate change and human development. They face hunting pressure. They face fragmentation into isolated populations. They face genetic bottlenecks where entire populations descend from small numbers of individuals, reducing genetic diversity. These are precisely the factors that appear to have contributed to mammoth extinction. Understanding mammoths helps us understand modern conservation challenges. Climate change, in particular, has become a central concern for modern conservation biologists, and mammoths are often invoked as a historical example of climate-driven extinction. The warming at the end of the Ice Age reshaped entire ecosystems. Species either adapted or went extinct. The mammoths, despite their evolutionary success, could not adapt quickly enough. Today, as human-caused climate change proceeds at historically rapid rates, we worry about similar pressures on modern species. Species have less time to evolve or migrate. Their habitats are transforming faster than in any previous period. The mammoth serves as a cautionary tale. In Arctic regions, the melting permafrost has become a source of fascination precisely because it preserves mammoth remains. The ivory and bones emerging from the thawing ground have become a resource legally harvested and sold in some regions, with debates about whether such harvesting is ethical or sustainable. The fact that mammoths, extinct for thousands of years, can still provide economic resources speaks to the richness of what they left behind. The genetic legacy of mammoths has become particularly significant in recent years as ancient DNA technology has advanced. By sequencing the genomes of mammoths preserved in permafrost, scientists have gained insights not just into mammoths specifically, but into how DNA degrades over time, how species evolve, how populations decline genetically before they go extinct. This genetic knowledge has applications far beyond mammoths. It informs conservation strategies for modern species, helps us understand how to maintain genetic diversity in small populations, and provides data on the evolutionary biology of extinction. The prospect of mammoth de-extinction has captured public imagination. If scientists can clone mammoths from genetic material, the argument goes, why shouldn't we? We have the technology to potentially create mammoths, or at least mammoth-like creatures. Some argue this would be a form of restoration, a repairing of damage done by human-driven extinction. Others argue it is hubris, a misuse of technology, an attempt to undo extinction that might be better directed toward preventing modern extinctions. The debate is ongoing and unresolved, but it speaks to the power that mammoths hold, even extinct. They fascinate us, compel us, make us ask deep questions about our relationship to nature. In culture and art, mammoths continue to inspire. From the Paleolithic cave paintings at Chaucer and other sites where mammoths were depicted by ancient artists, to modern reconstructions and museum displays, mammoths remain subjects of intense artistic interest. They represent a world now lost, a time of giants and ice, a period of human history that seems both distant and somehow more authentic or vital than our present moment. They appeal to romantic notions of wildness and authenticity that modern humans, living in cities and digital networks, seem to crave. The lesson of mammoths, if we are willing to learn it, is multifaceted. First, it is a lesson about extinction itself. Species that seem dominant, that have evolved successfully, that have persisted for millions of years, can still go extinct. Extinction is not rare or unusual, it is the ultimate fate of all species. What is remarkable is not that mammoths went extinct, but that they persisted so long. Understanding this can help us be humble about our own species' future. We may seem dominant now, but evolutionary success offers no guarantee of permanent persistence. Second, mammoths teach us about the power of combined stressors. Neither climate change nor hunting alone may have driven mammoths to extinction, but together they created conditions from which recovery was impossible. This is relevant to modern conservation in a world where species face multiple pressures simultaneously. Habitat loss, climate change, pollution, disease, and hunting all converge on many species. Success in conservation often requires addressing multiple threats simultaneously, rather than focusing on single factors. Third, mammoths teach us about the importance of genetic diversity and population connectivity. The fragmentation of mammoth populations, the isolation of Wrangel Island mammoths from mainland populations, the decline in genetic diversity, all of these were precursors to extinction. Modern conservation emphasizes maintaining corridors of habitat that allow populations to remain connected, emphasizes genetic management in captive populations, emphasizes the importance of preserving genetic diversity. These strategies, developed partly based on understanding how species go extinct, are direct echoes of what we have learned from mammoths. Finally, mammoths teach us about our own power. For most of human history, we were minor players in global ecosystems, but by the end of the Ice Age, we had become significant predators capable of shaping ecosystems through hunting. By today, we have become the dominant force on the planet. We shape climate, we fragment habitats, we drive species to extinction, but we also have the knowledge and capability to prevent extinction and to restore ecosystems. The story of mammoths is a reminder that we have always had this power, but we are only now, in recent centuries and decades, beginning to understand and grapple with what that power means and how we should use it responsibly. The mammoths are gone, but in their going they have left us with knowledge, with stories, with questions that remain pressing and vital. They have left us with a legacy of extinction that can teach us, if we are willing to listen, about the fragility of life, the consequences of environmental change, and our own capacity to shape the future of the living world. And so we come to the end of our journey backward through time, to the conclusion of a story that has taken us from Ice Age mammoths to modern laboratories, from the spears of ancient hunters to the genetic codes preserved in frozen remains. The mammoths are gone. They vanished not in a moment, but across millennia, as climates warmed, habitats transformed, and human hunting pressure intensified. Their extinction was not unique. Many species vanished at the end of the Ice Age, but mammoths remain iconic, memorable, invested with significance that transcends their role as extinct animals. They represent a lost world, a time of giants and ice, an era when humans and megafauna coexisted and hunted each other in landscapes now utterly transformed. The questions we have explored tonight: why mammoths went extinct, what climate and human hunting contributed to their disappearance, what their extinction tells us about extinction in general, remain partly unsolved. Science continues to refine our understanding as new discoveries emerge from the melting permafrost, as genetic analysis becomes more sophisticated, as our understanding of Ice Age climate becomes more precise. But some mystery persists, and perhaps that is appropriate. Not all questions have neat answers. Not all mysteries can be fully resolved. The mammoths keep some of their secrets, and we are all the richer for it. If you think back to the beginning of this journey, we began in a world of ice and giants, a landscape so different from the world we know that it seems almost alien. We walked through that world as hunters, as mammoths, as witnesses to the great transformation that ended the Ice Age. And we have traced the decline and disappearance of mammoths as both climate and human activity intensified. But there is another perspective from which to view this story, one that is perhaps more intimate and personal. The mammoths that lived and died in that Ice Age world were not abstractions. They were individuals, mothers and calves, old bulls and young females, creatures with personalities and histories and ways of experiencing the world. Each mammoth that was born lived a life shaped by the landscape, the climate, the other mammoths in its herd, and eventually perhaps by human hunters. Each mammoth that died was an ending, a conclusion of a unique existence. We cannot know what it was like to be a mammoth, to experience the world with mammoth senses, to navigate Ice Age landscapes with mammoth intelligence. But we can imagine it. We can use our scientific knowledge to reconstruct what mammoth life was like, and we can extend our empathy across the vast gulf of time that separates us from them. And in doing so, we can acknowledge their reality, their dignity as creatures, their worth beyond their utility or their extinction. As you rest tonight, as you drift towards sleep, carry with you this image, the vast steppe of Ice Age Siberia or Ice Age Europe, a landscape of grass and sparse shrub, the air clear and cold, the light slanting at unusual angles because of the high latitude and the specific angle of the sun. And across this landscape, mammoths move. They move in family groups led by wise matriarchs who remember roots and seasons and dangers. They move in vast herds, hundreds or thousands of individuals, their presence shaping the landscape through their grazing. They move with purpose and awareness, these giants, these creatures that dominated their world for millions of years. And then the world changes, the climate shifts, the vegetation transforms, the herds fragment. Humans with spears arrive, become more numerous, more skilled at hunting. The mammoths decline generation by generation until the last individuals die in the Arctic. Cold, and the mammoths pass into history, into extinction, into the fossil record and the frozen remains that we study today. It is a story of power and fragility, of dominance and decline, of creatures perfectly adapted to one world, suddenly finding themselves in a world they could not survive. But it is also a story of us, of human creativity, human adaptation, human power to shape the world around us. The mammoths and humans coexisted for thousands of years in an intricate dance, predator and prey, each shaping the other's world. The mammoths are gone now, but they live on in our understanding, in our science, in our art, in our imagination. They live on in the questions they raise about extinction, about climate change, about the power of humans to alter ecosystems. And perhaps most importantly, they live on in the lessons they teach us about responsibility, our responsibility to understand the living world, to cherish it, to recognize our power to harm it and to use that power carefully. So as you drift towards sleep tonight, let the mammoths accompany you. Let their stories settle into your mind like snow on the ancient steppe. Think of the hunters who tracked them, the landscape they inhabited, the slow transformation that led to their disappearance. And perhaps in that space between waking and sleep, you will glimpse something of that Ice Age world, something of the mammoths themselves, their great shaggy forms moving across a landscape now lost to time. If you have found this journey through time meaningful, if you have felt even a small measure of peace or wonder in exploring these ancient worlds and mysteries, I would be grateful if you would consider liking this video and subscribing to our channel. Each like and subscribe helps us continue to bring you these immersive historical journeys, these deep explorations of worlds that have passed away but never truly vanish from our imagination. Thank you for joining us on this long walk backward through time. Thank you for lending your attention to the story of mammoths, to the questions of extinction and climate and human power that their disappearance raises. The mammoths' reign has ended, but their legacy persists, carried forward in the mind of anyone who has ever wondered about the Ice Age giants and the world they inhabited. Sleep well tonight, accompanied by mammoths and memories of ice.